Hello, welcome back to my tech fun. Kingroon sent me another 3D printer for the review, and this is KP3S Pro V2, a Klipper based printer which is able to print very fast. The print volume is 200 mm in X, Y and Z direction, and it used the linear rails on all three axes. Now, according to specifications, it is able to print on 350 mm per second speed, somewhere it says 500, and 10,000 mm per square second is the acceleration. This is very big speed and acceleration, and we will see how it performs. It has all-metal direct extruder with a gear ratio of 9.5 to 1. This means it can provide very big torque if necessary. Now, the downside, I think, is that according to the specifications, the maximum temperatures are 260 on the nozzle and 100 degrees Celsius on the bed. Probably it has that Teflon line hot end, so in that case I wouldn't recommend you to go about 240 degrees Celsius, but I'm waiting the confirmation from the Kingroon. In the meantime, I got the answer from the Kingroon. It has all metal hot end with full metallic heat break, so this means that we can go easily to those 260 degrees Celsius. And that nozzle I will mention later, it is from hardened steel. And it has 1.25 inch display. I never saw this small display with the Klipper printer, but we will see. Probably we want to use it anyway over the network, over laptop or maybe app. It has auto bed leveling sensor, and it has very small footprint, because the first KP3S I tested, it was very small printer, but the power supply unit was separate, requires a space on the desk, and also the filament holder is next to the printer. With next generation of KP3S, the power supply unit was built into the base of the printer, but still the spool holder was next to the 3D printer. And finally, here I can see from the pictures that the power supply unit is in the base of the printer and the spool holder is on the top of it. So this really has a very small footprint, which requires this very minimal space on the desk. Let's see what's in the box. The packaging is good, everything is nicely protected in this black foam during the shipping. This was content of the package. As you can see, it is very pre-assembled 3D printer. We have this base and this, I know, half gentry, or I'm not sure what is its name in English, and I can see this is the inductive auto leveling sensor and direct extruder. As you can see, linear rails on all three axes, the screen, and this is the lead screw. It was in this pipe to be protected. And then we have some cables, sample filaments, but without the spool, and you know me, I really hate this kind of solutions. And this is the spool holder, and this bearing will just protect the lead screw, so it has to be loose, don't worry about that. And yes, one important thing, I can see they use this textile PI sheet, which I really like, and it is two-sided. Let's take a closer look at the base. So here we can see some specifications of the printer. On the front side, this is some connection for the HDMI cable, the slot for the TF card, and a USB Type-C plug. And this is the left side. This is the wire for the X motor. It's a little bit loose. These other wires goes to the extruder. This is the Ethernet connection and some USB plugs too. Immediately I noticed one possible problem. I'm not sure, I'll have to pay attention to this. This is the cable for the hotbed, and I just tried to move the hotbed, and you can see it's stuck here. Okay, so I have to do some kind of holder or something like that, because this may be the problem if during the printing it stuck. I checked the packaging list, and from this the adapter cable and the network cable is missing from my package. And in the package I have this spare nozzle, and I'm just curious what is its material. Is it brass but coated with something? I have to check with the Kingroon, but you can see it now on the screen. I've started the installing of the Z-axis to the base, but an important step which makes your life easier is to pre-install these bolts and T-nuts into this block. But be careful, because in my case they are installed upside down. They have to be in this position, and now I can slide the Z-axis from the top, but I will tie them later after the main bolts are tightened. These are just temporarily inserted but not tied. The main bolts has to be tied from the bottom, because they will secure the square position of this Z-axis. Well, I stuck here even on the first step because according to user manual from the bottom I need M5 by 8 mm bolts, but in this package I have M5 by 6 or M5 by 10. And anyway, it is not deep enough, so I have to cut this thread a little bit deeper. And now it's deep enough. And now it is completely in and I can tighten the rest of the bolts. And now inserting the lead screw into T-nut and the coupler, and I can already see that it has some lubricant on it. Installing the spool holder, and again I don't have a proper bolt, so one will be M5 by 6 and the other M5 by 10 millimeters. Connecting the display and just snap into the position. Connecting the power cable, and also don't forget to check the voltage if it is set correctly for your country. In my case it's okay. Before I turn it on, just quick look to the extruder. I can see a lot of gears here, so that's why we have this ratio of 9.5 to 1, because we have this very small tiny pancake stepper motor, and there is that inductive auto leveling sensor. I cannot see any limit switches, so I hope it used that sensorless homing, but again I can see that this hotbed cable may cause a problem, so I have to solve it before I turn it on. I designed and printed this part from the black PLA. One more time you can see why we need this part. Actually on my printer it's necessary. Countersunk bolts M3 from one side and washer and then nut from the other side. And now I don't have to worry about this element. I will upload it to the printables if you will need it too. It would be good to have some kind of aligning pins. Let's turn it on. It boots after approximately 50 seconds. I'm not sure is it only the first time or every time. On most of the other printers where we have this knob, it operates in opposite direction. I'm not sure how much time I need to get used to this screen, but yes, not too comfortable for the use. Very small text screen actually. Definitely I want to plug to the network as soon as possible. I could do this over the cable too, but I would like to connect to the Wi-Fi, and I have to enter my Wi-Fi network and the password to this configuration file on this USB drive. This file on USB drive I have to open with the notepad, and then I can enter here my Wi-Fi username and password. Now back to the printer, turning off, and I'm not sure which USB port I have to use, but let's try the first one. Let's see if it was successful. Okay, because if I see here the IP address, then the connection is good and I can enter this into my browser on the laptop. This is a screen from my laptop, and from here I have a lot of possibilities how to control my 3D printer. So connection is good, but now I have to insert the filament, level the bed, and then to print something which will be from the USB drive, because that G-code is prepared by the manufacturer. Let's prepare the bed, which should be easy because there are no leveling knobs and the springs. The position of the bed is fixed. Level. First I will set the Z offset. Very strange method for moving on the Z axis. I have to choose from the menu. Okay, -1. Here I have to be careful not to hit the nozzle to the bed because there are no springs to compensate that. As you can see, I'm using double sheet just in case, because I'm not sure how good will the material stick to this PI sheet. Just for first printing. Save. And now auto leveling, which will record some kind of offset mesh, and then it will be compensated during the printing if necessary. Input shaper. This is very comfortable that the sensors are built in the printer, and in a few minutes it's finished, the fan turns off and I can see that the Klipper restarted and it's ready for the next step. Now let's insert the filament. I'll try to use these sample filaments, I hope it's enough for the Benchy. And be very careful because you have to supervise this, it may easily fall down from this. I'm preheating the nozzle and I'm setting the temperature, but I have the feeling that this should be reversed because in this case it is increasing and clockwise it is decreasing. Usually it is in opposite direction. Flood filament slow. It's going in, okay. I can see it was tested with some orange filament. And this is some kind of white silk. And I'm still missing the tweezers in the packaging. Print, USB, Benchy. And as always, the first printing will be the G-code, which is prepared by the manufacturer. Later I will prepare the slicer and slice my own G-code. I'm not sure how they prepared these G-codes, but the purge line was next to the bed here. But anyway, the Benchy start was quite fast and it is okay so far, but it's very loud. Oh, especially now. Approximately finish the layer in 5 or 6 seconds. This is the back side of the printer and definitely it is good that I printed this part here. Sample filaments. Good advice here. Wow, and this is crazy fast. After approximately 7 minutes, the printing is at 25%, and I'm very curious about the quality of this Benchy because approximately it will be printed in 25-26 minutes. The printing is at 63% after 14 minutes, but I noticed one scary thing a little bit. So this probe is very close to that printed object, and I'm not sure is it loose and coming down or it was like so from the beginning. So I have to pay attention to this just in case, but maybe after the printing I will raise it at least 1 millimeter if possible and set again the Z offset. 84%, 18 minutes, and soon it will start with the bridging. Printed in 22 minutes. Immediately I want to check the bed adhesion. This is good. Okay, it's not coming down, so I can trust it. I have to wait until it cools down and we will see then. The bed cooled down to 32 degrees. Oh. Now let's analyze this Benchy. Not the perfect one, but it was printed very fast. Okay, let's start. The first layer is okay, there is no problem with it. Then I can see that the part cooling could be just a little bit better. It is very critical here on the biggest overhang, but it's very close to acceptable. Now, then I can see on this chimney that these layers are printed too fast. So here it could use more part cooling or slower, bigger time between the layers. And what I don't like the most is the top layer, top finishing layer here, and also from inside. It looks like they use only, I don't know, one covering layer or something like that, but definitely it needs more. And maybe just a little bit more stringy than I would like to see with the PLA material. But this is very promising anyway. It's time to prepare the slicer, and for this we have these files and instructions on USB drive. Those files has to be copied in the Cura's resource folder. These are those folders we have to open to copy the files, and after this, if I want to add a new printer, the Kingroon Pro V2 will be in this list, and this calibration cube, which is also a dice, will be the first object, and it will be printed in 6 minutes according to the Cura. And I am sending this job over the laptop. uploading the file, and this is the real-time footage. So you can see this is quite small file and it requires some time until it's uploaded. Later I will upload it over the cable. It's much faster, and I can start the printing from here. This time the purge line is on the print surface. And the start is good. And after approximately second layer, it turns on the fan and speeds up significantly. Unfortunately, from the front we have this fan shroud in the way, so we don't have a good view to the object, only from the side or from the back. It's printed in 11 minutes, which includes the bed and nozzle heating time. That's impressive. Bed adhesion is great. The bed is 35 degrees Celsius. Let's try to remove it. It sticks too good. I think I will set the Z offset again, but with the preheated bed. I already checked the accuracy in X and Y direction is good. Only in Z direction it's a little bit bigger. This means I cannot really, if I raise the Z offset, in that case it will be even bigger, so I'm not sure what should I do with that. But let's check the quality. And I don't really like the top surface, so definitely maybe this is too fast for it. Sides are okay, and I can see no ghosting from the vibration. And this is the first layer. In my case, I noticed that sometimes it lost the connection, and now it is reconnected with a different IP address. This is not the big problem during the printing if the job is already sent to the printer, because it stored that file. But I think I will try to connect with the cable, and it will be more stable and even faster, especially that upload of the bigger files. My next printing will be in spiral or vase mode. It will be a low poly vase, but I have to scale it down because I want to print this from the sample filament, and I have here only 5 meters. I would like to test this method too, but I think the Klipper can handle this without any problems, but let's see it. This is the first layer. And this is the second layer. This is now the vase mode, but I can see this is definitely too fast for this mode. I can see the layer didn't stick to each other. I have to slow down the printing. But the start is great. I will restart the same G-code, only over my laptop. I will slow it down to maybe 40% only. And this time the printing along the spiral path is smooth and the printing is without problems. Now, because of this failed print, I don't have enough filament for this vase, but I will leave it to use this filament too, and I will see the result. Just for fun, I will try to pause the printing and then I will replace it with this orange PLA, but I never had good success with replacing the filament on the spiral or vase mode printing. The spot of the replacing is always visible. New filament is prepared, and I have to wait until the previous one runs out. My first attempt will be over the fluid. Here I have the command automatic filament change. Let's try that. I tried to follow the instructions on the screen or on the printer. The unload of the filament was okay, but when I insert the new one, the problem is that the nozzle is above the object. Now definitely this needs some tuning from the software side. I tried to automatically replace the filament. The unload was success. Now it's loading or doing something, I'm not sure. But definitely this, when it stops, should move to a side, so the purge is not on the object, but somewhere on the bed. Now I will stop the printing. Well, as I mentioned, I couldn't really finish the printing, but what is finished, it looks great, and I really like this seal color on the low poly vase. This point is very easy to remove, but I left it here so you can see what happened when I stopped the printing to change the filament. It should move to a side and not staying above the object. Maybe this is because of the vase mode printing, I'm not sure, but definitely it needs some tuning in the software side. My next printing will be this articulated dragon from Printables. And according to the Cura, the printing time will be approximately 3 hours. Just for curiosity, if this would be printed on KP3S1, the printing time would be more than 12 hours with the same settings. Huge difference. With this object, this first layer is very important because it has a lot of independent elements and each of them has to stick good to this bed. And the first layer looks good. Only I worry about at the end because it sticks too good to this bed and I have to remove it each separately without breaking the object. The first layer is finished and each element looks perfect so far. After 24 minutes the printing is on 10%. But the progress is good so far. As always, I'm measuring the noise from exactly half meter distance from the hot end, and I will be quiet now. Looks like the average is approximately 69.5 decibels, and that's very loud. The printing is at 31% and the printing time is a little bit more than 1 hour, so it will be approximately more than 3 hours of printing. Looks okay so far. After 2 hours, 62%. Printed in 3 hours and 9 minutes, and for the first look it looks great, but I will wait until it cools down and to see how easy it is to remove the object. Whoa, it's coming down. Well, here it is in one piece. It looks great, only I can see most of the elements are fused together, but theoretically this should be flexible, so I'll try to release them and then we will see if I can make this work. I feel like a chiropractor. Well, after approximately 10 minutes of post-processing, I could free all elements without breaking them, and now it is completely functional. And my daughter has a new toy now, but probably she will break it in the first day. We will see. One more time I want to change the filament, but now completely only over the 3D printer, so without my laptop. I will start that calibration cube and I will try to change the filament. It will start in the orange color and then I will try to change to the white at the end. Okay, let's try again. Pause the printing. And this is not what I want, because I want it to move aside, because I cannot change the filament in this position. I can assume the printing level, input shape, language, print, temperature, filament. Yes, here I can unload and load the filament. The problem is that it is above the object. Let's try. Unload. But this is not the good method. Color is changed, but I'm not sure is the purge enough, and it was about the object. Well, the color is changed. Here there is a spot from the oozing of the nozzle when it was in orange, and the purge was actually now inside in infill, so that's why it looks okay, but this is not the good method for the changing the filament. And now the conclusions. Well, this was really refreshing after all those ND3 clone review videos for me. And this printer is great from the hardware side. Linear rails on all 3 axes, great direct extruder with accelerometers inside and inductive auto leveling sensor. I really like this two-sided texture PI sheet. Maybe the object sticks too good to it, but I was always able to remove it, so it is not critical. Now, only I don't like this screen. It is really small, so definitely if you want to use the Klipper only with the screen, you will have a bad feeling, like a big step back. But definitely much better is if you connect it to the Wi-Fi or over the cable and use it from the screen, from the laptop. I had some problems when I used the Wi-Fi. Sometimes I lost the connection and it requires some time until it reconnects. And when I switched to the cable, from that it was perfect, and even the uploading the file was much faster compared to the Wi-Fi connection. From the software side, I feel that it requires some improvements. I'm not too familiar with the Klipper, but for example, I tried to change the filament during the printing over the screen and it wasn't successful. I'm not sure is this the correct method, but I just followed the instructions on the screen. Later you saw if I try to do it regularly, old-fashioned method, manually from the screen on the printer, then it was successful, but this is not the correct method to do this. Overall, I had very positive experience with this printer. It is very fast, no question about it, but it is also very noisy, so pay attention if you want to use it in your office or something like that. Of course, it is always possible to slow it down. I think the biggest noise is basically from this part cooling fan, and actually you can reduce the part cooling. In that case, you will get a quieter printer, but in that case, of course, you have to print slower a little bit. If you have some other experience or your suggestions, a few lines in the comment section. Thank you for watching and happy printing!